Welcome to the CMC Podcast, Aerial Ladders as High Directionals for Rope Rescue. I am your host of this one, Kelly Byrne. Joining us is Rescue School leader, coordinator, Wayne Chapman. Say hello, Wayne, so we know your voice.
Good morning, everybody. How you doing?
There's Wayne. We got Doug McElmury, CMC rescue instructor. Doug, tell everybody hello.
Hello there.
Awesome. And also joining us on this podcast, we have the one and only Mike Forbes, a fireman from Spokane, Washington. How you doing, Mike?
I'm doing great, Kelly. Thanks.
Awesome. Mike and I have been friends for about 10 years. We met on the firehouse.com forum talking about, of all things, aerial ladders as high directionals. So Mike reminded me of that earlier when he and I were talking earlier today, and I'd totally forgotten about that, but that's kind of how our paths crossed. Yeah.
Yeah, that was quite a while ago. Yep.
Yeah, sure was. So Mike's a tillerman in Spokane, Washington. He is a fellow rope geek and also the owner of ropecraft.org. So, which Mike does a lot of testing and presenting at the International Technical Rescue Symposium. And is a numbers kind of guy. Is that roundabout correct?
I think that'll work. Yeah.
All right, fair enough. So has your opinion changed in 10 years on aerial ladders as high directionals? We'll get to what it is, but have you changed it since we started talking?
No, I was reading that forum podcast, or not podcast, the forum post the other day, and I still agree with some of the initial questions I had in trying to seek answers for our department. And I'm still a little bit hesitant as to using them as a high directional. I think that's where some of the potential problems lie. And that original post that got the discussion happening was about using them as a crane as well. And that's a whole different can of worms. But a lot of people have a lot of opinions on that on both sides of things, crane and as high directional. They're very different.
They are very different, and they load the ladder markedly different. I know my interest in it. I guess I'd always had an interest in it because I'm a fireman in Washington D.C. We had used aerials as high directionals, often. And then I saw the video of Pat Rhodes talking about aerial ladders as high directionals. He used a vortex as to stand in place of an aerial, and it definitely got me interested. And I definitely did not agree with everything he was talking about, but it caused me to go down the path to learn more information. Currently, I don't think they're a great idea. I think there's some good to be had from it. But Wayne, you have mentioned you used them often. Yeah, you're totally okay with it in all situations, or just
no.
Specifically rigged?
Not all situations. So again, for the listeners, my background, as well as 33 years in the fire service, mainly at truck companies, I spent 16 years as a FEMA rigger. So I attended numerous courses around cranes. So I kind of used both of those for my background. I think most importantly, since we had an incident in my previous department, we actually put a committee together and we got with the manufacturers. So everything we came up with, the manufacturers approved. And then we took that information, and then we decided as a department, well, we're not going to let our guys do these certain things because it takes too much. It's too much going on. So we're going to show them, here's how you do it. And again, I am not into moving, you don't pick up loads with them. It's essentially a high point. Right. And I've said this a whole bunch of times to anybody that will listen. Minimize the load, right? Maximize the degree of aerial elevation, minimize aerial extension, keep the ropes, think resultant, and just think of crane theory. And that's how we've always done it and had great success doing it.
Yeah. I mean, that's interesting. What kind of incidents did you guys have? You said, are you at liberty to talk about it? You said that.
Yeah. I mean,
you guys to look at it.
One was an electrocution up on a 2-story roof of a residence, right? So, and again, the way the department was set up, an Arizona vortex as a high point, which is not an option, especially on a residential roof, right? And it takes time.
Sure.
And this guy was in bad shape. We got there, and right, typical Southern California, numerous news helicopters flying overhead, and pulled off the rescue super quick. And then another one that I remember is we were called into a neighboring department's area for a double drug overdose up on a roof. And again, same thing. And even the crew that we responded with, the battalion chief was like, wow, that was quick. And it's like, we practice this all the time.
It definitely is quick. It is quick. And I've done pretty similar calls. My look at it all and my take is how do we square the tip load on a high change of direction with the manufacturer's specs. If we get a tip load of 500 pounds is what they give us, and we're put a change of direction up there and we're putting 700 pounds, like how is, I haven't, my issue is how is that okay, I think. So Doug, what's your experience with aerial ladders and rope? What are your thoughts on it all?
Well, very similar. The only way we do use it is a high directional. The main brands of aerials that we used in our region here was Pearson E1, and same thing as Wayne. We went right with the manufacturer's recommendation to a point. And both of them had information, and even sold the equipment with a high change of direction pulley that would attach right on their piece of aerial apparatus to use it as a high directional, and then using something as a hull at the bottom. So that was kind of the way we went about it.
Fair enough. I've had really bad luck with manufacturers trying to get specific info, and definitely nothing in writing. I know, some of the latest ladders I've been dealing with, they were spec'd out with the tip rollers. They were spec'd out with anchors on the trailer. But the manual about, 200 pages deep said absolutely do not use these two in conjunction with each other. Like they gave us exactly what we asked for, and then told us they basically wrote directions and buried it way deep that you just could not use them. So, I mean, and, to the manufacturers, like some manufacturers reference the CMC manual as well. But I mean, it's pretty specific in the CMC manual. Don't use hydraulics to move the load, right?
Mm-hmm.
So, I mean, it's interesting that they would direct you to rig it a certain way that you would want to use hydraulics, and then refer you to something that tells you don't use hydraulics.
The minute you start using hydraulics, you're in a different world now, right? That is, so for us, it was always that aerial was parked, and that was it. But the minute you start using hydraulics and you start moving, right, when you boom out or change boom elevation, the math changes totally, right? And, even in the crane world, you pick up a load and you move through the quadrants of a crane.
Yeah.
The radius change depends on the type of crane you're using. So ours is strictly a high point.
So like fixed, you could turn the ladder truck off and
absolutely
use it cold that way.
Yes.
Interesting. My take on it has been just from looking at the numbers and putting a load cell at the tip, and I think just directly tying to the tip and using hydraulics it puts the least amount of tip force on there. So, Mike, in your research, have you found any of that? What have you found with tip loads and moving loads under hydraulic power and all that?
Yeah. So when we first started when I started looking into this, went direct to the manufacturer and had pretty good luck with talking to them directly. And I remember one of the phrases they told me was, we don't really care where the load's hanging, whether it's standing on top of the rungs like you're a firefighter on the egress tip, or whether you're hanging from the bottom. I mean, obviously there's a dynamic element that can happen, if you're bouncing around, but that can happen either hanging below or above. Sure. So we have those three different configurations that we were talking about earlier, where one is just the load hanging below the tip off that lifting bar. And then we also have a little secondary point of attachment. And we hang it from two Aztecs. We never lift the load off from unloaded aerial to a loaded aerial with the hydraulics. We have two Aztecs that hang down to either an unattended Stokes or individual rescuer. And then we'll load it carefully with the Aztecs. And then once it's floating and the tip is loaded, at that point we'll be able to check to see what our forces are on the aerial if it's outside of its operating range. But we limit it to the same tip load, 500 pounds for our aerial.
Okay.
And then fly it as can be. And it Pierce, the manufacturer, was totally fine with that, and that I think is in their manuals as being an acceptable practice.
Yeah, cool. I'm okay with that. I think that's the for me probably the best way to do it, to get the least amount of tip force. So Wayne, I'm not a FEMA crane guy at all. What is the opposition to using hydraulics to fly somebody out?
Well, I think more than anything, it's the danger of it, right? I mean, for example, if you boom out, try to extend the aerial without giving out rope, it's not going to be a good ending. You're going to suck the guy in through the pulley. Same thing when you retract the aerial, right? The rope's going to get longer and it'll hit something.
What about just direct tying to the tip? Like, is there any, like, just put a couple of 2-point webbing anchors off the tip of the ladder and just use the, raise, rotate, and extend to fly the load around that way? Any issues there?
No. And I guess I looked at it from a different perspective of, the longer, the more stick you have out, right? Remember, the fulcrum is, in this case, the rams.
Yeah.
Right. So the more stick you have out, right? Think of a crane. The more boom you have out, the chart is different than the less boom you have out, and the degree of elevation is the same thing. So we just took that exact scenario and used it for rope rescue.
I don't disagree with that. We've got a 60-ton rotating boom wrecker, and we've got a load chart for all angles and elevations, and off the side or whatever. Aerial ladders, we don't get that. They give us one number for the most part. They put a load chart on the pedestal.
And we never. There's no need that I can see of to ever have a litter attendant. We never did it. Right, get the load down. We use the tagline. Just get it down. And when you consider the max boom you could really stick out to about 100 feet.
Yeah,
let's get the guy down.
So again, I agree with that as well. No attendant is not a bad best practice. My question that it generates in my mind is, what other rope rescue scenario is our go, no go, a 300-pound margin? Like 300 pounds, single person, like, yeah, we can do it. An attendant, like, absolutely not. Like, that seems to be too little of a margin for my level of comfort. But I mean,
well, we did not do an attendant due to weight. We just did it for for speed.
Ah, okay, fair enough. Shoots a big fat hole in my argument. So, Mike, what about you guys? Attendants or no?
Avoid them at all costs, just to minimize the load on the aerial.
Okay.
Yeah, and so if it's just hanging from the tip, it's permissible depending upon the type of person you'd be flying. But really, we're going to keep everything under that 500 pounds.
Okay, yeah, fair enough. Doug, do you think otherwise on any of that?
Yeah.
Okay.
Our main purpose was for some product tanks. And
was for some what?
Product tanks.
Okay, yeah.
Like unexpanded polystyrene pellets or chemical tanks where they were working. So we wanted to quickly package it and get them done. So definitely no attendant was the best way to go.
Okay, yeah, I think so too. The tip load, trying to get around the tip load thing has always been my big one versus direct tie or change of direction at the tip. We'll talk about that in a little bit. But, I did a fair amount of looking at all the rigging. I did a paper or a presentation rather in 2016 at the International Technical Rescue Symposium on fire department high directionals. I was super interested in it, did a bunch of research, and I would advocate that anybody who's interested in it, put a load cell on the tip of their aerial ladder, put a couple 100 pounds of weight hanging beneath it, and just see what you come up with and make up your own mind. One of the interesting things that I think people misread, or maybe it's me who's misreading it, is aerial ladder construction. People want to rig it and treat it as if it is a column and not a cantilever truss. do we think that any type of trying to put this resultant down the bed of the aerial to try and put it in compression, like is that not the best thought? Mike, you're a numbersy guy. What do you think on that? Column or cantilever truss?
Oh boy, that's outside of my. They totally behave differently in my look at engineering and dabbling in that world, but I can't speak to that. I know, like the LA County book refers to them as a column.
Yeah.
And I know you talk about it as a cantilever truss and how they buckle and the Euler buckling methods and all the different ways that the tension in the top and the compression in the bottom. And
sure.
Boy, I think that's going to be more of a question for the engineers in the world.
I think so too, but I'm not an engineer, and I was hoping you had the answer. But my engineering friend pool is not very deep. So one of the issues I had when I was testing these aerial ladders out, I wanted to test them at different extensions and elevations. So I put 300 pounds in a Stokes basket, and was just trying to extend the ladder and see what my lower cylinder pressure gauge was reading versus my tip load, and just get all the numbers I could. I don't know what I was going to do with them, but I was just trying to get something that I could look at in the future and maybe analyze a little further. One of the things I ran into, though, was when we were trying to run a change of direction at the tip. 4 out of the 6 ladder trucks I tested this on initially could not extend past like the 80-foot mark. And, the problem we were having was the resultant, I think, was pushing down so hard on the ladder that it wouldn't extend between the ladder binding and the resultant pushing down, which I wouldn't have thought that would be enough to do it given the weight of the ladder. But we just could not extend the ladder. Our hydraulic system was maxed out at 80 feet with the change of direction. We had no issues like that with a just tied directly to the tip or putting a mechanical advantage, 4-to-1 block and tackle directly on the tip. Has anybody had any extension cylinder issues, or is it just the lackluster maintenance where I tested them?
Was that only on your 250-pound tips, or did that go with the 500 as well? Because I know you did it on both.
I think it was just the 250s, but I think the difference in tip load is just a function of the outriggers, how wide the outriggers go. And we've got, the little A-frame stabilizers, small, so we can get under cars in the city. But I think it was just the 250s. I don't remember doing it with the 500s, but it's been a couple of years at this point.
Yeah, I've not experienced that. We were able to extend and retract in that reeved crane configuration where we run the hull system down the bed of the aerial. And
so, talk about that. We talked about it pre-show. We didn't talk about it while we were actually doing it. Tell us about your reeved crane configuration. How you guys do that?
Yeah, and so it was created out of we had a pretty significant snow year where we had, 5 to 7 feet of snow in the city, and then subsequent rain fell on it. And so we had a bunch of building collapses with unknown whether there were people trapped inside or not. And so you have these unstable exterior walls with an interior wall collapse. And so the concept was to be able to lift a rescuer up off the ground, fly them in, and then lower them down into the center of the building where shoring wasn't needed, evaluate for life safety, and then be able to extract and swing back out and drop them off outside the collapse zone. And so what we came up with, working with the manufacturer, was more or less 2 sort of progress capture devices. We're using the MPD at the base of the aerial there with the rope running up and over the tip. We're using those roof rollers, the gold roof roller, kind of lashed to the tip.
Sure.
Right now, we're getting the new manufacturer-made pulleys for the tip, but ropes pretty much go over the tip and down to the load, brought together with a doubled long-tail bowline, and then attached to the rescue package. On lower, it's really easy. There's just two operators running the MPDs, lowering the load in and out. And
sure.
Then when we want to raise back up, build a 3-to-1 on the rungs, right in the bed, and depending upon the load that's on the tip, we may or may not run the haul system long on the aerial, depending upon how far it's extended, just to minimize the load at the tip. And raise and lower like that. It does take some coordination between the aerial operator and whether you're raising and lowering. We try not to do those things at the same time, hauling and moving and running the hydraulics and whatnot, but it moves so slowly that we have not run into any problems with it, and it's been very effective for numerous different rescues we've had around in the city. So
cool. It's it seems like a good way of rigging and works for you guys. Maybe I make too much of it, and just much ado about nothing. I would imagine the rope running underneath of the ladder and over top of the ladder, like the force wouldn't change. It would be the same on the ladder, I would think. Yeah. Mm-hmm. With all configurations like that, I've been able to go over, with a 300-pound load, I've been able to exceed, 500 pounds pretty darn easily. So I don't know. Maybe it's just fine. Go ahead. Sorry.
I should say that when we run it in that configuration, we limit the load to 250 pounds.
Oh, okay.
To account for any potential tip loading. Okay. The manufacturer says you can run it at 500 pounds like that. And so the more I was thinking about that, if I think about it, like when we mount a lockhead winch or a Harken winch onto a vortex leg, our resultant is just down the end of the rope. Because it's part of the frame. It's really no different configuration. It's just 100-foot version of it than the vortex version. It gets into a little weird resultant discussion there, but
totally. And I wonder at what place it's like. I don't know where the dividing line is because I'm not just don't know it. But like if you bolted a vortex to a building, then you in fact have a result. Like there is resistance to it. I didn't know if the weight of the ladder truck itself is the opposition force.
It was interesting because the manufacturer will say, like I think Doug was referring to this earlier, that when you bring that rope up over the tip, it needs to be anchored back to the handrail, or they make a bar that goes in there, and they were okay with using the bottom rung,
right?
Or
sure,
the square tube. But they say if you anchor outside of the aerial, then you run the risk of putting extra force and amplifying the force on the tip. And so it's exactly like using a high directional, where you put it outside the high directional. Now we're driving a resultant and dealing with a force multiplier. Yeah. It's pretty interesting.
Yeah, I think it's. I wish I was smart enough to understand it, or like at least argue intelligently about it, but I don't. So I think if we can find a way for people to respond to this podcast and ask questions or provide input, that would be super cool. Like I need to know more because I'm still ignorant of when it comes to the forces there, how that works out.
Well, maybe if I could comment on, take him on what Mike was talking about. I've actually got a copy of them that I think the same manufacturer you're talking about, Mike, with the where they talk about where you anchor, and literally it specifically says, working end secured to anything other than the ladder handrail will limit the capacity to 250 pounds or 1/2 of the remaining tip capacity. Mm-hmm. And I know that the same manufacturer too cautions against basically anchoring off on the main rung due to the aggressive anti-slip rungs on there. And they specifically talk about the damage that can be done to the rope because of the grit on the rungs.
Sounds like a writer's test to me.
Yeah,
I was going to say.
Yeah, there you go. Yeah,
let's talk about rope.
Yeah, ironically though, if you tie it to the handrail or to the ladder handrail at the base, it really comes in close to a lot of other, to a lot of the mechanics of the aerial too. As you're going up, and granted, as long as you don't move the aerial, you're in good shape. But there are some secondary issues if you mount it the way they do, and of course, then their recommendation is to use the extend and retract to raise and lower your victim. They don't talk about them. it'd be nice if they put in writing in their manual exactly like what Mike talked about, because that's very similar to what we did.
Sure,
we anchored MPDs at the base, and then we instead of running it up over the tip, we actually ran just shy of the tip through a roof roller, went out, and then we had a double pulley that came off of an anchor strap. So it kind of split the load off of two spots there. Mm-hmm. So very similar, though.
Yeah, definitely. I mean, ladder trucks are like firefighting pieces and should be used like for firefighting, I think. And, I don't know. Like, I wonder if they'll, manufacturers just put in whatever you ask them to. I don't know, like how much thought actually gets put into the rope rescue side of things. I've never been able to make contact. I haven't tried very hard, but, my follow-up question to all of that is, when we're talking about the loads and, minimizing the load, how do we account for the belay impact on that ladder? Like every single belay impact we're going to have is going to exceed the tip load of that ladder. So how do we square that? Do we just say it's probably not going to happen? Or, Wayne, I know you said you used to belay separately if at all possible, right?
Yes. So we had kind of a hierarchy, if you will, right? And number one was that we always belayed independent of the aerial. So, most of our rescues were a concrete tilt-up type of a building, right? So, my one firefighter would go up with a rope bag on his back, find an anchor up on the roof, and that would be the belay line, right? So if anything happened to the aerial, the belay was completely independent of the truck company, a complete separate system belayed off of the roof, right? Worst case scenario. Now, right. So now you got to talk about, are you talking about old, dedicated belay days where the belay would slack? Or you talk about the more modern systems where now both lines are tension, right? Because you're talking about different forces that are applied should one of those lines fail. So obviously the older school stuff, the belay impact is a significant issue.
Sure.
Which is why at first we started going off away from the aerial. Now, I've since left, but now I believe they do, we're doing twin tension, which we were doing then, but incorporating the aerial, the twin tension is right. Kind of the same principles we use in a typical rope class.
Sure. So, and the reason you ran the belay separate, but still the main line up high was just, because the high point is what you needed and it was fast. Yeah. And the belay separate is just essentially, hedging your bet a little bit.
Yeah. The unit that I was on at the time did not have a vortex, right? So you get up there and the fastest way, the ones I had done, you had patients in extremely critical condition, right? Again, we didn't use the aerial just because. Right. It was, it needs to happen right now. And, so again, it was, we just did that to hedge our bets. Because remember, this started in the old days under the slack belay system.
Sure.
And it's moved forward into that twin tension rope system world.
No, fair enough. My next question that leads me to then is, are aerial ladders bomb proof? Mike?
The wheels and axles and outriggers on the ground. I might go down that path, but tow hooks, things like that. But aerial sticking
the hydraulic portion, though. Yeah,
I'm not comfortable with putting all my even though we are hanging off the bottom of it, and I don't know if that's an acceptable risk for the scenario at hand. And I definitely don't view the aerial as like the go-to, because it can be easier than dragging somebody up a hill to like just reach that thing out over a hillside and pick them up and swing them to the roof. to the road. But
sure.
I think it's okay for us to work a little bit and using an aerial on a steep angle, let's say, while that may be tempting, just to like put it out over the edge and fly them up to the road. That maybe that's not. That's not the best hierarchy of risk management there. I think.
No, I definitely agree with that. I've had two aerials in my general vicinity of operation, Mid-Atlantic, that have had catastrophic failures in recent history. One of them just a couple of weeks ago, a relief valve failed on a hoisting cylinder. Like, the manufacturer's like, don't worry, that doesn't happen that often. Like, well, that doesn't make me feel a lot better, like, all right, maybe our other 12 won't do it, but I don't know, that bummed me out. And then there was a swaging end on an extension cable that failed on a ladder, and both of these incidents happened on a morning checkout, which speaks to the importance of doing a morning checkout. But guys put the aerial ladder straight up, not straight up, but whatever, pretty high elevation and extension, and it came crashing back, at a violent in a violent way. So I don't think ladders are bomb proof, and I would, much like Wayne was talking about running your belay separate, I would run my belay separate if I could. And at this point, I'm a hard sell on them right now. I would not use them. If I could run a belay separate, I think I'd try and run the whole system separate. But again, I might be making much ado about nothing.
Yeah, I'd agree with you there all day long. I think the time and place for them is when there really isn't, when there really aren't good opportunities outside of the aerial. So
I definitely agree. I also think that mixing firefighters with hydraulics and rope is like the devil's three-way. Like, you just got the three things that firemen and hydraulics should not mix that often. Firemen and ropes, maybe, yes, on occasion, but to mix the three of them together, just to me seems like a recipe for bad things happening. I don't know. Again, maybe I'm just a hard sell.
Yeah, bad things happening was what made us go through the manufacturers, because we had a bad thing happen. Luckily in training.
Sure.
Right. And it was the first and only time in my organization's history where the training chief came out and said, okay, training is over. Now we're going to stop this till we fix this problem.
I mean, good on him for doing that then.
Yeah.
I maybe I ought to pursue the tracking down manufacturers a little harder. I did it with one manufacturer. They sent a fella out, and he asked if I was a frustrated engineer, and I was like, no, I just got questions. And I was left not satisfied with the answers I got. So, I continued down my search for numbers, and I don't know.
Yeah, I mean, again, I think if you look at like a crane, right? When you hear the rating of a crane, right? If you hear a 40-ton crane, that means the crane can pick up 40 tons 10 feet away from the center pin.
Okay.
It can't pick up 40 tons at mass extension and all that stuff. So, I mean, I've worked around 40-ton cranes where you can't pick up 2,000 pounds at max boom and a bad boom angle, right?
Sure.
So it's kind of the same thing, right? The farther you stick that stick out and change your elevation, it's the math is going to be different for every boom angle and boom elevation. So max, right? That was our rule. Maximize elevation and minimize aerial extension, just to the point you needed to get it down.
As much as I hate rigging to the lowest common denominator, I think thinking about things like that with an aerial ladder while we're doing rope rescue, is just not the first thing on people's mind, like it would be a FEMA rigger, which, is a shame because it probably should be, and I think it's just another, check mark in my box. And again, I'm biased because I think I've mostly have my mind made up that we shouldn't do it for the most part. So that's
Wayne,
go ahead, Mike.
Wayne, I think you hit the nail on the head there. We always in the fire service work with that one number, like our 500-pound tip, but in the crane world, it's so different, and that it just really reiterates the point of, like you said, max elevation and minimum extension. We're only going to be benefiting ourselves, as opposed to just thinking, I got 500 pounds anywhere I want to go. And maybe you do, but you also dip into your safety margins dramatically when you start, running things at the far extent.
Yeah. And I think too, one of the important things we've got to talk, all these techniques we're talking about are, especially when you're running down the bed of the ladder, you are inherently, if you're not perfectly centered, you're close to center when you're centering the load on the ladder. And if you look at that aerial failure that was in our region, they were 18 inches off center when they anchored. And then it was basically a high directional going down to a tow hook, but yet the ladder was off center of the rig.
Yeah.
So there's a torsional load. And when they did the after action study on this thing, they said they don't believe that the tip load was ever exceeded. It was the torsional load which caused the aerial failure.
Yeah. So that was the Mundelein, Illinois ladder failure, right?
Mundelein,
yeah, Mundelein. Yeah. It's highlighted in the National Fire Academy put out a book
USFA.
on that.
Yeah,
that's what it was.
And it goes through it nicely, some good pictures of it.
Yeah.
And I think that's where I really get nervous when I see people use the aerial as a high directional and then run the rope under, because where are they anchoring? Because it's like, it's so inconvenient to go to the bottom of the ladder. Let's go to the tow hook, and then somebody gets ready. Okay, let's rotate the ladder.
Yeah, that's
or you go to a jack or an outrigger.
Yeah,
sure. And you're perfectly in line.
We did that, right? We ran on the underside, with the emphasis being that the rope is centered down the aerial, right? In fact, on our newer trucks, we had the manufacturer put in a hook specifically in the center because of that. And I ran off to the side, and no, you do not tie off the outriggers.
Really?
Yeah.
All right. I mean, it's hard to argue with the manufacturers if they're the ones putting it out there. You kind of got to go with what they say, whether it's tip load or where you tie off to.
Yeah. Our last aerial too, they actually mounted two U-shaped connections at the base of the aerial, basically right above or right below the heel pin. So we did a twin tension system, went up their proprietary pulley system, came down, and it was almost idiot proof to rig the thing, because it was so easy to connect in your anchor straps, your MPDs right into those two U-shaped anchors at the base.
Sure. What is the word? Ignorance and motivation can yield some pretty interesting results. Don't underestimate somebody's ability to mess up two U-bolts.
Oh, this is true.
Yeah, right. And Kelly, and that's, I think, one of the reasons why we were so strict because again, the manufacturer said you can do this, and we said, we're going to only tell them they can do these couple of things, right? Because again, we didn't want the guys to have a lot of options, because the more options you give them, the more they're going to go outside of that. Now, again, being a large department that we didn't have, 25 of the same types of trucks.
Right.
We had baskets in certain divisions. We had tillers in certain divisions. Right. So you couldn't always run over the top.
Sure.
When you have a bucket, that's a little complicated. Right?
Yeah. Right.
All the hydraulics are in there.
Yeah. Gin pole or some in the bucket.
So the underside solved that problem for us. And again, that particular manufacturer was bragging about how strong their aerial was, basically calling it a box beam.
Sure. I mean, and I mean, some of them are. And I've got one. We've got an aerial scope where I work, and that thing is pretty awesome. It's pretty rock solid. We're still tying directly under the bucket with two ropes, like no pulleys, but I mean, I'm pretty comfy with it. That one's pretty strong. So in closing, I don't think we're as far apart as I thought we were. Like I'm still not sold on the high directional, whether it be over the top or underneath, no matter whether it's tied to the ladder or elsewhere. Like I need somebody to beat the physics of that into my head before I'll agree to it. But my mind can be changed, I think. But best practice is something I do think we can agree on. No attendant, I think there's no issue there. Like just both for speed and for minimizing the weight. Pulling in line with the ladder, I don't think we have any opposition to that. Whether we directly tie to the tip or put maximum mechanical advantage on the tip, I think there's some difference there. Like I'm a direct tie guy in Max MA. On the tip kind of guy. If you can't direct tie, I'd be comfortable putting a block and tackle up there. Mike, I think you're kind of there, or no? Tying to the tip?
Oh, I'm there.
All right,
tie to the tip. I'll put a block and tackle on it as well. Yeah.
All right.
That's my preferred method, is tie to the tip. So.
Yeah, I think so. I mean, anybody have any other closing thoughts? I've got a few here, but I'll let you guys go first. Wayne, you got any?
No, it's funny you should bring up the block and tackle theory, because that was one of the things we did not allow our guys to do, again, because it was much more difficult to obtain a resultant right? Because you had to have pretty much, 70, 80 degree boom angle to keep that. And the other problem our manufacturer had was the hauling, right? The jerky movements, right?
Sure. Yeah.
On a block and tackle versus on a system that ran under the aerial through some directional pulleys and across the ground. The guys were able to walk, and it allowed for a much more smoother ride, whereas the block and tackle, it tends to be a very bouncy pull on the aerial.
Yeah, fair enough. I guess I was analyzing it only statically, but no, I think there's definitely a lot to be said for that. Doug, any final?
One other question I would have too on the block and tackle is, your release string on your block. If you're using a standard 4-to-1 with an integral progress capture, I mean,
sure.
How long do you have to extend that handle? Because obviously you don't want to put somebody up in a stick, and now you have the potential for problem with that getting tangled up with your system.
You just put a guy on rappel under the block. No, I don't know. I don't have a good answer for that. That's a very fair operational point. I was only looking at it from a force perspective in that one. Mike, closing thoughts on this? You got anything that we hadn't covered yet?
Nope. I think we covered everything.
Yeah,
pretty well. It's great.
I think so too. Thanks for being on this podcast with us. I know you and I are, friends outside of podcast world, but it's always good talking to you. I bounce a lot of ideas off you in general, but definitely kind of neat to circle back around a decade later on, aerial ladders and rope rescue, which is what got us talking in the first place. So
it is. It's good. Yeah.
Yeah. Super fun. I think for me still, and it's one of the reasons I reference ITRS often and like going there. And I think you as well, Mike, and Wayne and Doug as well, like doing your research and seeing, what numbers you get for yourself are kind of how you're going to figure out what the best practices are. And, there's no, group or army of researchers doing this. It's usually just some, curious firefighter or, search and rescue guy who wants an answer. So, that's how I got further down the aerial ladder track. So, do your own research, make sure you're within the limits of what the manufacturer says is okay. And just always question what you're doing and why you're doing it. Don't just do it just because, like, do it with a purpose. If you're going to use an aerial ladder for rope rescue, I would suggest, doing it, knowing exactly what forces you're putting on it. And I think all four of us can agree on that one. Mm-hmm. Cool. I think there's still more to be hashed out with aerial ladders and rope rescue. Maybe we can get together with some manufacturers at a point in the near future and really put the screws to them and see what kind of numbers we can come up with from their engineering group. But I think that'll do it for this podcast. I appreciate everybody listening, and we'll talk to everybody soon.